Hey guys, in the previous section we learned about functional combinators. We've been working hard on our composition, keeping everything pure inside our programs. In this section, however, we're going to begin looking at impure functions, specifically I/O, since I/O is the reason for the season. It's what gives our programs meaning. It allows us to accept input from and share information to our users or other programs. We'll also continue to write our small presentation slide app that we began in the last section. We'll be building that up into a little complete running app that'll be able to display presentation slides stored as JSON. So in this section, we'll start by learning how to create a generic container that we can use to box up I/O. We want to keep this stuff away from the rest of our program. Can't be mixed up with our pure logic, but we aren't performing I/O just for kicks. So we'll need to see and use results, which means we'll also need some way of working with the I/O that we encapsulate. The container we'll be building for our I/O will open the door for a quick dive into lazy execution. And we mentioned before how JavaScript eagerly evaluates code. Most languages do this. However, we don't always want everything to be lazy, unfortunately, The container we'll be building for our I/O will open the door for a quick dive into lazy execution. We mentioned before how JavaScript eagerly evaluates code. Most languages do this. However, this isn't always what we want everything to do. Sometimes we want certain parts of our program to be lazy, and we'll be able to use our container to create some laziness. In the third video, we'll hook results from impure I/O into our compositions. And we'll begin to give some shape to our slideshow app that we're building by creating. In the third video, we'll hook results from our containers into our composition, and we'll begin to give some shape to the slideshow app that we're building by actually displaying some of the slides. Let's get started with the first video, encapsulating I/O using generic containers. We touched upon isolating impurities in the first volume, but we didn't do much with it because we didn't have as many tools as we do now. So we'll be implementing something similar here, but using generic containers. And we're going to cover containers, of course. They're very important in functional programming. Although they're not always referred to as containers, they go by a lot of other names and have many other properties to them. And they are very useful, but they also form one of the highest barriers into functional programming. So rather than trying to get over that high barrier immediately, we're going to take a different approach. We're going to go under the barrier by just using these generic containers, and they'll get us where we want to go. As mentioned, I/O is important to any program, but it's also dangerous and a source of bugs, so our container will help protect our code from impurities. Functional code requires us to think differently. Since we have to separate pure and impure code, we'll typically have a pure composition that takes its initial input from an impure operation or does something impure at the end of the composition, and probably both. We'll need to send things into a container in the latter case, and in the former case, where our pure functions are being kicked off using information from impure code being ran, we need to be able to do something with values produced by I/O that's encapsulated in our containers. So let's get started and create a container we could use to cover both of these cases. Okay, we're back working in the browser. Our app will be using the DOM rendering setup from the last volume, but for this video, we'll just be using traditional DOM manipulation functions to better emphasize where the impurities are happening in our script, rather than using JSX and our DOM rendering function, which would abstract that a bit more. Let's look at this insert HTML function. Seems harmless enough. But we know it's impure because it interacts with the DOM, and that's external state. We can't be sure what's going on in the DOM. We can insert an h1 tag with the class message into the DOM. No trouble, because we as people happen to understand that the element packed pub app is in the document object model, and we're interacting with it. It's been in the repo since volume 1. Then we can add some HTML into that element using the insert HTML function, which will also work because we just put the h1 message element in there. So we know it's there. We can see in the browser that this works. However, if we ran these functions in reverse order, there would be an error. So they aren't referentially transparent. We should be able to say, just by the arguments a function takes, those values, what it would return. And we can't do that here. So these aren't pure. Let's drop an SVG into the packed pub app element. And now let's run the insert HTML with the same arguments as before. Now, in the browser, we can see that the SVG is there, but we have an uncaught type error, cannot set property inner HTML of null, because we tried to insert a message into an element that doesn't exist. So we were trying to access a property on an object that isn't there. We know that we can just check to see if the element is there or not, right? We probably do this all the time. We can say that only if elem exists, then we'll try to change the inner HTML property of that elem. But this still is a problem because it's still not referentially transparent. So it's less error prone, but it's still not pure. It's a side effect. We see it works, but if we called this anywhere inside a composition or pure function, that code or any code calling it would no longer be pure. So let's start to create a container. We're going to use the ES6 class keyword here instead of just writing a constructor function with prototype methods. I think this is easier to read. Some people don't like it for pretty much that same exact reason, that it doesn't do anything different. It's just syntactic sugar. We're making an IO container. This container takes a function for its single constructor argument. We'll actually take the time to write in a constraint that will throw an error. So we're going to throw this message if the argument passed to the IO container constructor isn't a function. We use ramdoes is function to check if the second input value is an instance of the first value, which has to be a constructor function. That's why we passed uppercase function. Only if this is not true, so if it's not a function, then we'll throw an error message explaining that IO container expects a function, and using whatever type this is, using the type function, we'll show what type was actually passed in. Alright, let's just pass the constructor a number and see if it throws an error. We can see there in the console that yes, it does give a nice little red message. IO container expects function, actual number. Now, let's pass to the IO container an actual function and see what happens. We only put it into an IO container, but the container doesn't do anything with the function besides save it to the this.value property. So if we run the value property of the IO container, then we should have our function ran. In the browser, we can see that it is working. It says in big letters, I am a side effect. So how could this be useful? We still can't run this within a pure function, right? Because it's not pure itself. But we can create this in a pure function. Impure functions aren't radioactive. They can't emit impurities when they're inside a container. So if we write this function, I am pure, well, now we can pass in selector and HTML input values, and we can just drop the insert HTML function directly in here, or we can call it directly from in here. In either case, we get a container returned to us with a function that query selects our selector and conditionally changes its inner HTML. Nothing happens. the container is an object. Pure functions are allowed to return objects. It's not doing anything wrong. It's not doing anything at all, actually. Let's give our container a method that will run value, because we don't want to be reaching into the container and calling functions ourselves. So we don't want to call value ourselves. This perform.io function will just run the function inside, keeping our hands clean. If we run the perform method of the IO container returned from pure function, we see that over in the browser, we should now have an H1 that says safe and sound inside my container. Let's allow a function to be passed into perform. And then perform can still just call our impure function, but additionally, if we pass a function into perform, it will call that function with the results of the IO operation that's contained inside the IO container, because our IO might return something. We might want to do something with that. We could pass the value to a pure function. Now we can create a container with a function, checks the inner HTML of the H1 tag. We'll just pass console.log into perform, and over in the browser, here we can see the value inside H1 is being logged out to the console. Console.log is also an impure operation, so ideally we would have passed a pure function into perform, but no worries. Containers can do cool things. They could even allow us to work with the DOM in a more deterministic way. If our entire app is rendered inside a container, we could build our UI in a pure way by simply building a JavaScript object that represents the DOM, working with that object in a pure immutable way, and then having one impure function inside an IO container that took that object and translated its structure to an impure DOM operation. That's essentially what Virtual DOM does for us. Since we have Virtual DOM set up in the project already from Volume 1, we don't need to build this out.